Doing geometry by counting the square units on the inside is actually pretty easy. I just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But honestly, I kind of lose count a bunch of times. So I need a better way to count without counting the boxes. And honestly, the higher you go up in geometry, the harder it gets. The more little boxes I got to count, and it's kind of driving me crazy. So today we're going to learn how to calculate area without counting the boxes. But to do that, we have to take away the boxes. So to kind of get our brains ready for that, let's think for a second if polygon A and polygon B have the same area. Like, that's kind of weird to think about, because if I look at A and I look at B, A is definitely a square, like hands down that's a square. But if I look at B, like that's not even a quadrilateral, man. Like that's not even a quadrilateral. I think it has 7 sides. 1, 2, 3, 4, 5. There's 7 sides on the quadrilateral, but it's got like a hole in the middle. Well, I don't know. What do you think? Does A and B have the same area or not? Oh, but see, I bet you I could cut off that little tab sticking out of B, and then if it fits right over that hole, well, I don't know if it fits over the hole. Do you think that'll fit over the hole? I don't know. I actually don't know. You're going to tell me what you think in the comments, though. Write in the comments whether you think A and B have the same area. But the point here is I want you to be practicing words like square units. How many square units are in A? And if I look at B, how many square units are in B? Will that be the same? And what I'm talking about is the area. The inside blue part is the area. The perimeter is the outside. So like that black line would be the perimeter. So I think the perimeter on B is kind of weird. It's like there's 2 perimeters, right? I don't know. How would I be able to prove that both shapes are the same? Well, I could print them out and then put one on top of the other, right? And then cut off that little tab. That little tab is kind of bothering me. And I can't really calculate their area unless I have something to measure it by. I need to know how many square units are on the inside. And I can't do that unless I actually have a square centimeter or square inch to measure it by. So I don't know. So let's just go back to graphs for a little bit. So the question here first is, do any of the shapes have the same area? Like, do any of them have the same blue spots? Well, I kind of think C and D are a trick. It looks like D fits into C, but C is a different part that's colored blue. So I guess if the question is, do any of the shapes have the same area? Then I need to calculate the area of each one of those. Okay, so for A, I kind of don't want to count it one by one. Does that make me lazy? I don't know. I kind of don't want to count it one by one because I know a fast, quick way to do it. I'm just going to cut that shape into 2 shapes. And then I'm just going to take the base and height of the first one. And the base is 6 and the height is 2. Or the other way around. And I multiply those 2 together, and then now I know there's 12. It's kind of like an array. And then so I'm just going to do that on the bottom shape. The base and the height. Well, the base is 3, and the height is 4. So, well, 3 times 4 is 12. So I could say the whole area of A is 24 units squared. The whole area of A is 24 units squared. So now I just need to find whether one of these other blue shapes is 24. Okay, so B is kind of easy, right? Because, well, the base and the height, well, that's 6 times 6, and 6 times 6 is 36. Oh, wait. But see, now there's that empty spot in the middle on B. I don't know. Oh, I bet you, okay, so how about I just subtract it? Because, okay, so I could do the base and height of this negative area, I guess. I could do of this empty spot, and that's a 3 by 3, and 3 times 3 is 9. And so 36 minus that 9 would be 27. So I'm going to say the area of B is 27. So far, none of them are the same. Okay, so now we're going to get into C. Now C, I can't do base times height. Well, okay, so how am I going to do C? Okay, oh, do you see 4 triangles? It just dawned on me that there's 4 triangles. C is not a square, it's 4 triangles. You see that? So when I calculate the area for a triangle, I actually do base times height divided by 2. So if I'm doing base times height divided by 2, then I see on one of those triangles, that is 4 units tall and 2 units wide. But wait, look, all of them are 4 by 2 and 4 by 2 and 4 by, hey, that's kind of weird. All the triangles are 4 by 2. So if I wanted to figure out the area of one triangle, I would do base times height divided by 2, which means I would do 4 times 2 divided by 2, and that one makes it 4, and that one makes it 4, and that one's 4, and that one's 4. And that's weird, they're all the same. So 4 plus 4 plus 4 plus 4 is 16. So far, none of them have the same area. One has 24, one has 27, one has, well, 16. Okay, so let me give a try on D. Now D, it looks like this base here, it looks like I could just lay it flat, but the truth is I can't. That is a hypotenuse, and I'm telling you, never trust a hypotenuse. You think they're doing one thing, but they're not. Never trust a hypotenuse. That's my lesson in life for you. Never trust a hypotenuse. So if I lay it flat down right here, you can see that it's actually bigger, that it doesn't lay on the graph nice and easy for me to count. So I actually can't count it that way. I can't do base times height. Well, maybe I could cut it up into triangles. What if I put a line here, but then I still can't lay the base down flat? Okay, get rid of that one. What if I put a line here and make a triangle? Because see, now it's kind of like a hat. Oh, wait, but I still can't lay the base down. I got a parallelogram in the middle. Oh, I kind of don't know on D. Can you leave me a comment and help me with D? Like, I'm a teacher and I'm supposed to know this, but I kind of don't know what to do with D. Don't judge me. Do any of the shapes have the same negative area? Oh my God. I didn't think about that. Like, the negative area means the part not colored in blue. Oh my God. Oh, wait. Okay. Sorry. I know how to do D, but I'm not going to tell you yet. You're going to have to wait till the next video. Oh my God. I feel so smart. I just figured it out. Well, the main point of this is I wanted you to maybe decompose the shape into negative area and then recompose it into something that's a lot easier to calculate. Maybe you're going to have to rearrange some blue parts and some not blue parts and maybe make some triangles instead of those squares. Maybe. I don't know. I feel like I want to stop this video now and go show you how I did D. Okay, I think I will. All right. Well, that is the end of this video because I got to go make another video so I can show you how I did D. I feel so clever. Okay, bye.